Okay, so we already knew the value for this one. So we need still to know the value of RB cross F2. And since we don't have enough space, so let us proceed to another paper. So we have, but let me copy first this one. The value of F2, copy. So we have F2 and the value of our RB. Let us copy this also. Copy and then paste. Let us paste it here. Ayan. Yan. Therefore, to compute the RB cross F2, we have the I, J, and K, right? Then the value of our RB, we have 4, 5, and negative 2. And for our F2, we have 80, 40, and negative 30. So this is in terms of fit and found. Okay. So to determine again the value of our I, J, and K, let me copy this one 3 times. So we have need to determine I, we need to cover this part and do this pattern. Okay, so we have for I, we have 5 multiplied by negative 30 minus negative 2 multiplied by 40. So our I here is I think it is equal to negative 70. Yan. Okay, so this is the value of our I. And then for the value of our J, so we need to cover this part and do this pattern. So we have, since this is J, we have a negative sign here, and then 4 times negative 30 minus this way, we have negative 2 multiplied by 80. And this is equal to negative 40J. And lastly, for the value of K, need to cover this and do this. So we have 4 multiplied by 40 minus 5 multiplied by 5 multiplied by 80. So this is equal to negative 240K. Okay, so all in all, our RB cross F2 is just equal to negative 70I minus 40J minus 240K. Okay, since we already know the value of these two, Okay, going back, since we already know the value of these two, we can now compute for the totality or the resultant moment. Okay, but first let me copy our RA cross F1. So let me copy this and paste it here. Yan. Since we now know the value of our F, I mean R1 x F cross F1 and RB cross F2, we can now add the value of the two. Well, this one, so we can now add the value of the two. So we have for I component, we have 100 minus 70, so we have 30 I. Then for our J, since we only have a negative 40J here, so we can copy this. Since our RA cross F1 has no J component, that's why. And lastly, for the value of our K, we have 300 minus 240 is plus 60K. So all in all, our moment at point O using a vector notation is that we have a 30I minus 40J plus 60K. Okay, so all in all, our moment is 30I minus 40J plus 60K, and we can plot this in our X, Y, and Z to show it in the coordinates. So say this is our let us still adopt the X, Y, and Z orientation based from our given problem, and let us now plot this moment at point O. So we have these values, so we have 30 minus 40 plus 60. Say since this is a positive 30, say 1 2 3, say this is 30, and then we need, since negative J, we need to go about negative 40 to the left, 1 2 3 4, and then positive K, so we need to move 60 to the right. Yan. Say this is our moment 30I minus 40J at point O plus 60K. And also we can since we have this now final illustration of our moment, we can also determine the coordinates and the direction angle. So from X, say the direction angle from X, say this is alpha, and to get the value of our alpha, again based from our previous topics, the value of alpha is just cosine alpha is equal to x all over the length of this, say h, and this h here is the square root of 30 square plus 40 square plus 60 square, or equal to around 78.10 a. So therefore our x 30 all over 78.1, or our alpha is just equal to cosine negative 1 x over h. We have 30 all over 78.1, and this is equal to 67.4 degrees. Okay, so our alpha here is 67.4 degree. So this is the value of our alpha. And same process to determine the value of our beta, or the angle from positive y-axis. So let's call it beta. So again, cosine beta is equal to y all over h, wherein beta is equal to cosine negative 1. Y is negative 40 all over this one, 78.10. So this is equal to around 121 degree. So our beta is around 121 degree. Okay, and lastly, for the value of our this one, let us call this gamma. So same principle or same process to get the value of our gamma. We have a gamma is equal to cosine negative 1 the k all over h. So our k is 60. 60 all over h is 78.10. This is equal to 39.8 degree. So this is 39.8 degrees. Okay, so all in all, the moment created by these forces F1 and F2 is equal to this much, this one. Okay, 30i minus 40j plus 60k at 64.4 degrees from x-axis, 121 degree from y-axis, and 39.8 degrees from z-axis. Okay. So that's it, and that's all for this video. Thank you so much, and I hope you learned something on how to compute the movement using the vector coordinates. I mean the vector notation form.